Thank you very much.
We have to open the last session. So I invite personally Jacqueline from Volkswagen, who is present physically. So it's a great honor. Thank you, Jacqueline.
Thank you.
And then we should have, I hope, connected. We have, okay, Manuel. I see Manuel on the screen. Manuel Rossi is industrial director from Whirlpool, managing the Southern Europe plants, if I make it simple as that. And the third participant is from USA. We have Jack Liu. Jack Liu is an expert, a researcher of ergonomics from working for the NIOSH. Jack, are you there?
Here, can you hear me?
I can hear you, perfect. You look beautiful, okay.
Thank you.
So we have prepared a round table, a short panel discussion, and I would start with the first question to Jack Liu from NIOSH. And the first question is, which are the main technical innovations to prevent work-related musculoskeletal disorders in US manufacturing industries? So we focus on Europe, on Germany in particular, but I would say in Europe, and I'm particularly interested to listen from you about what's happening in US. So please, up to you.
Sure, sure. I can really evaluate the effectiveness of this new technology. I'm gonna speak to you, which you're probably aware of, is industrial exoskeleton. This is a very hot topic right now in the US. The ASTM, the US, one of the main US standardization body, formed the F48 committee. And within this 48 committee, they have several subcommittee, and one of the biggest one has a focus on human factors for exoskeletons. And this center, ASTM Center, is growing very rapidly, and they just formed a new called a Center of Exoskeleton Center of Excellence, where you can find a lot of new findings from different research. And I personally have a project as well to evaluate the passive shoulder exoskeleton at NIOSH. And I just came back from the US Human Factors and Ergonomics Conference last week in Atlanta. The attendance of this conference grew a lot, about 1,500 people from all over the world. I did not see many people from Europe. I did see a couple from Germany. I don't think I saw any from Italy. And during the conference, there's probably a quarter to one third of the presentations about exoskeletons. So, but at this stage of the research, I still don't know if exoskeleton is a good new technology for solving the MSD problems in the workplace, because one of the field study that just came out from the US from Maury Nussbaum's group at Virginia Tech University, in partnership with the Ford automotive industry, the company, you guys know Ford, right? And the study indicated that in the long term, in about 18 months of tracking the MSD rates for users of the passive shoulder exoskeleton, they really did not see the significant difference in terms of their rate and the discomfort in their shoulder and several body regions. So I would say, I don't want to waste too much time for the group, but I would say the industrial exoskeleton, it's a very, very hot topic right now in the US, and potentially could be used as a new technology to prevent work-related musculoskeletal disorders.
Thank you, Jack. This is a hot topic in Europe as well, and we are working hard with also the medical scientific world to find a way to measure the effect. Second question is for Jacqueline. Jacqueline from Volkswagen. The question is, which are the key characteristics of EAWS which made the Volkswagen Group choose it as the global Volkswagen standard ergonomic system? So what happened?
Well, of course, I will speak about my professional experience as an ergonomist working at Volkswagen Auto Europa for the past 20 years. And so I can highlight firstly as a key feature that EAWS is state-of-the-art to analyze relevant loads in production automotive industry. So when I started working, I remember we were using a variety of assessment tools to access workstation ergonomics risk factors. And we had to really do a deep dive into the demands of each workplace and then select the most adequate tool. So for one workplace, sometimes we were using 3 or 4 different tools, one to access upper limb repetitive task, another for whole body posture, another to access manual material handling, another to access fatigue or metabolic expenditure. And in the end, this was a very time-consuming analysis phase, and we had 3 or 4 or 5 traffic lights highlighting each workplace, and then it was very difficult to manage prioritization and implement corrective actions. So with the EAWS, of course, we have a unique tool that accesses a variety of risk factors that are present in our production line. And so we are able to manage much easily prioritization and corrective action implementation. And for me, so this is one of the highlights that I can speak about. Also, there is a very high compatibility with the MTM process building blocks. So we see that when there are line updates, mix changes, volume changes, what was happening with our tools in the past, they had no, let's say, direct link to the methods and times analysis that was being the basis for our ergonomic studies. And so our studies had a very short validation time. And every time there were changes, we had to update our studies. Now we are able to have this link, and the studies are updated automatically. So this is a big advantage.
Fantastic.
So another highlight or a feature.
We didn't prepare this.
No, we didn't. So maybe another feature is, of course, that, as you said, it is a standard tool in the Volkswagen Group. So plants are capable to be benchmarking between themselves, because we are able to compare our analysis. And well, a very good example of this is the Ergo Award that has been, of course, started in the VW Group by Industrial Engineering in about 2018, and where the plants and regions are invited to share their good practices regarding.
Who was the winner?
Regarding ergonomics. So it was a big honor that this year our plant won the 2021 edition. Of course, we were a bit late, and we had a really interesting measure that was implemented. Because, of course, there are standards for this competition. The measures must be from the production division. They must be innovative. They must be scalable, of course, for other locations. And they must have a benefit. And how are we measuring this benefit? Of course, with the before and after EAWS results. And so our plant presented the e-throne, which is a very interesting solution, because it's an innovative solution to transport people and allowing them to work in an underbody workplace, performing overhead tasks in a sitting posture with a height of adjustable chair. And it was a really interesting project because we performed this e-throne, like we have called it. It was all made in our lean center. So it's a low-cost solution. And we had this idea being given by the team leader from the production line, and it had all the feedback from the workers integrated into the solution. So we can see that we are really taking in hand what are the workers' needs and giving them the benefits that they need. So Another highlight you said for me to highlight the features is that we can use the results from EAWS, or at least in our plant, and I know the rest of the group is also doing it, not only for corrective or preventive actions. We are also using the results to plan organizational methods. So an example of this is a recent project that we are doing with PhD students with the Nova Science School of Science and Technology and the Faculty of Human Kinetics, where we are using a genetic algorithm to create a tool, a digital tool, to support the team leaders when they want to plan the rotation plan for the workers. And of course, this tool has high technical validity because it is using the AWS results. And the outputs, of course, is that the team leader can improve the time that he needs to plan the rotation plan, because we are shifting from a manual process to an automatic process. And also, there is a high monitoring of the workers, because the daily risk exposure is then recorded in the database. And so we can have positive outcomes for health.
This has a clear link in relation with the efficiency and ergonomic system. We have just seen in Carlos' presentation.
Yeah, exactly.
So probably, it is worth to compare and discuss this, this application. But there is one point I want to take out from very important, in my opinion, also for my experience, which is the link with Manuel, which is the integration of work analysis data, typically MTM or any kind of study, and ergonomic analysis. So the integration of the two data set, it is very relevant. And the question for you, Manuel, is since we are doing this in the project we are running with you in Cassinetta, in the plant. Cassinetta is Varese, my hometown. Manuel and myself and we are coming from the same city. Do you see a value in the integration of industrial engineering and ergonomics competencies, systems and tools? Now, which are the hardest roadblocks to win, to break down in our poor country, Italy?
Okay. So thank you for the question. Definitely, I do see a value in integrating those competencies, and I will try to tell you why. When we redesign a workstation, a workplace, our objective is to increase productivity, and we normally do it through non-value added activities elimination. One part of this non-value added is coming from non-ergonomical activities or movement. By eliminating those, by default, we improve ergonomics. The other, instead, are simply elimination of other movements that then translate into the increase of frequency of task. So in the end, the final effect of removing non-ergonomical activities and increasing frequency is not known until we have done all the analysis that normally were made through NIOSH and OCRA calculation index. So having the capability to consider upfront in the design phase the combined effect of what we are doing is saving us a lot of time. No? We do on paper, we don't modify anything until we are sure of what we are doing, and this is saving a lot of time and avoiding a lot of reloops. So this to me is the value. Then roadblock is that unfortunately today in Italy authorities do not know this methodology, and as a matter of fact is not recognized. So in the end we are obliged to use the two methodologies, OCRA and NIOSH and AWS. And this is somehow creating the obstacle in the adoption from our engineers that are confronted with having to do the same task 2 times. So I'm sure that once we will break this window and enter into the authorities world, I have no doubt that we will use one tool, which is AWS. because it has the design capability that Okra and NIOSH they do not have.
Thank you. Perfect answer, Manuel. This is a very relevant point in our country and also in some other countries, like, for example, in Spain, they have the same problem, in Brazil also. And, for your information, we from Fondazione Ergo are paying a lot of efforts. I'm personally involved in the ISO 10 working groups, reviewing the standards, the biomechanical load related standards like the 11228 series and the 11226 dealing with postures. And, scientifically, technically, we have demonstrated very clearly the alignment of EAWS with the existing technical norms. And we benefit from the very wide, application of EAWS worldwide, and Volkswagen is just one example. So be positive. We are doing that, and I'm sure that in the very short term we open the window. Quickly for a second round before sending everybody to dinner. I see, hungry faces here in front of me. A second question for you, Jack. How NIOSH is working to incorporate new technological solutions in its technical norms, dealing with biomechanical load. Francesco mentioned it a few minutes ago. A technical norm dealing with exoskeletons, but in general, what is the trend you have in US?
Yeah, we at NIOSH, I don't think everybody, even not just NIOSH, we don't have a solution yet. For example, I think some of those previous speakers mentioned about if you put the exoskeleton on workers, now none of the risk assessment methods apply anymore because your internal loading has been altered by the lifting or the shoulder access devices. So what we ought to do is really just to focus on the research part of this area to figure out how are we going to develop the new risk assessment methods. I really want to emphasize the method just because what we are doing right now, we're trying to so-called to automate the risk assessment method. But these methods were very ancient. They were developed by 80s and the 90s, you name it, the NIOSH lifting equation, RUDA, OWASP, ARIBA, OCRA. This is all developed more than 20 years ago. And right now we're using the new digital technology. We have a new IMU sensor information. We have computer-based posture information. We can get on a time series information. We have a lot of posture information. We have a lot of hand force information. How do we incorporate this technology into the existing method? It is indeed a challenge, but I don't see newer people or newer research group are working on the new methods. For example, most of the master NIOSH lifting equations really just address one aspect of your work life, lifting. But mostly people do lifting, they push and pull, they carry, they walk, they do different things, and they do some office work as well. So the method can only apply a portion of their work during the day. So if you use that risk assessment, say NIOSH lifting equation to represent their risk exposure, that's just not good. It's not good enough to predict injury. So I think I would like to emphasize that at NIOSH, we are working with partners to develop a new method. For example, I do plan on developing a new multiplier for the NIOSH lifting equation to address, say, teamwork, one-handed lift. Right now, it's not there yet, okay? I do plan on adding, our NIOSH do plan on adding more information to the existing methods, such as RUDA, such as ARIBA, and other risk assessment method by incorporating this new information from the technology, such as IMU and a computer vision-based posture information. Right now, the method only calls for the snapshot of the posture, right? If you look at a person's doing, that's the risk. But in reality, the risk is predicated on your continuous body movement, your continuous body coordination throughout the day. how do we collect that data? How do we apply that information to existing risk assessment method? It is indeed a huge challenge. I encourage all the attendees during today's conference start thinking about how can we all together and collaborate together, the US and Europe and the EU countries, to develop something that is actually more applicable to the modern job that is extremely variable right now.
Thank you, Jack. We will receive your invitation, and we will be happy to bridge our groups in further research projects. Thank you very much, Jack. Second question for you. So how well the Volkswagen operating model is capable to prevent work-related musculoskeletal disorders, but throughout the entire product life cycle, let's say at least from product development down to production, excluding the service which is out of the factory.
Okay, well, maybe speaking about the modus operandi that we had in our plant when we did the T-Rock launch in 2017, the first step was to do an ergo potential list where we documented all the critical processes that we had with the current model. And we used the information not only from the AWS risk assessment of the workplaces, but also the feedback and ideas from the workers. And we passed this list over to the product development team. And then we did weekly meetings with them with a very high focus on product change. What were we able to change at this phase or early phase of the product that were giving us some headaches in our series of the current model? Then when we did the 3P workshops in our plants, we simulated all the workplaces and evaluated them using a hybrid motion capturing system, of course, with the EAWS software.
3P means product, process, and?
Product. Let's ask Martin, maybe he can help us.
I miss one P, product, process, and people.
No. Yeah, you can.
I forgot. I worked with the 3P process at Lamborghini, but so planning
process,
okay.
Exactly. Okay. So in the 3P processes, even before we have our production line and the workers working, we are already assessing and planning the best working conditions. And so this makes it possible to, in the series phase, just validate these ergonomics evaluations, see if we need to update them. And this method allows for efficient, low-cost also workplace design, because we are beforehand very focused with the workplace design. And then in the series phase, we are just looking to see what needs to be corrected. So this is how we can give better working conditions to our workers.
Thank you very much. And it's important to have a standard process. That's why
of course,
we talk about the production system and operating model. And last question to you, Manuel. What is the state of the art of the introduction of EAWS in Whirlpool EMEA, or if you want to focus on your plants as you wish? I mean, which processes are we working on in which plants and what are the future expectations?
Yeah, as you know pretty well, we are introducing EAWS in the frame of the PMP project. So we are doing it in Cassinetta, in all our 3 factories, so refrigerators, microwaves, and oven. For the time being, we have chosen a model area which are 3 lines in those 3 factories. Then the plan is for sure to roll it out to the full Cassinetta site, and then following our priorities to the EMEA footprint, let's say. So I think this is where we want to be and where we want to go as soon as we have finished the lighthouse in Cassinetta.
Thank you, Manuel. So this makes me very, very happy, very proud, because EAWS has been, our baby for 4 years. And I believe that, regardless the situation with the recognition standards and so on the market, in the industry, EAWS has become really a global system. It's used extensively. I wrote a paper a few years ago estimating how many workers are working under EAWS design, and we have reached a tremendous number, and I'm sure that today, if we update that number, it will be, probably we overcome 1 million of workers. So guys, sorry if we are late, despite we work with TMUs. We broke the limit by 20,000 TMUs, more or less. I thank you, our speakers.
It was a pleasure. Thank you for hosting me.
Yeah, well, it's a pleasure. We see next week with our legs under the table, eating good food and drinking good wine. And Jack, I hope to see you soon in one of the next ISO meeting. We miss you. We miss fresh ideas.
Thank you for inviting me. You can hear me. My headset died earlier, so can you hear me?
Yes, we can.
Thank you. Yep. Perfect. Thank you for inviting me, Gabriele.
Thank you. Bye-bye. Good night and buon appetito.
Ciao.
Grazie.
Herzlichen Dank.